Welcome back, everyone. I'm Jordan Giesecke, and this is The Limiting Factor. Today we'll be discussing the publicly traded company, Talga Resources. I've been following Talga for 3 years, and my interest in Talga is what sparked the idea for this series on graphitic battery anodes. Talga has put itself in a strategic position to supply natural battery anode to the European market. In this video, I'll start with Talga's anode product and then walk you through Talga's mine and production process in northern Sweden. Before we begin, a special thanks to Bradford Ferguson of Halter Ferguson Financial and the Patreon supporters listed in the credits. It's the support on Patreon that keeps me grinding away on niche topics. Back to Talga. Talga unveiled their anode product called Talnode-C in May of 2018. The results were impressive. However, I take any performance figures from any battery or battery materials manufacturer with a grain of salt. I get as hyped as anyone about performance figures. However, it's best to look at this anode product as a business proposition. Does Talga have a viable product? Can they scale it? And can they turn a profit? Let's see if we can answer each of these questions. As with Novonix, my view is that we can use the rigorous testing of Talga's potential customers as a proxy to find out whether Talga has a viable product. Talga's potential customers are, of course, battery companies and automotive manufacturers. These customers have the equipment and expertise to test and qualify battery materials. If they're signing agreements with Talga, it answers the product viability question. We'll come back to this in a moment. First, we need to look at the path anode takes from lab to market. This image from Talga illustrates the stages of testing and the amount of material required at each stage. As you can see, each stage requires increasing amounts of material as higher levels of confidence are reached in the product by Talga and then Talga's potential customers. The qualification stage is where customers test the anode product. Qualification takes at least 18 months. The reason why 18 months is because battery companies need long-term cycling, consistency, durability, and safety data. If the anode passes qualification, customers decide whether to start signing agreements to purchase the anode. After qualification, the anode product then moves to moderate volume production of 1,000 to 2,000 tons per year. During this time, the customer validates that the anode manufacturer can deliver consistently at high volumes. This is how trust is built. After Talga is a trusted manufacturer and has an established process, that's when production will go parabolic. Where is Talga in this process now? Talga is currently running a pilot process with facilities distributed between Sweden, Germany, UK, and Japan. This is to supply moderate volumes of material for product qualification. In the meantime, Talga has already begun developing their Stage 1 operation, which consolidates the process to Sweden and will be capable of producing 2,500 tons of anode per year. This will prove their ability to deliver high volumes of product with high consistency. In 2021, construction of the Stage 1 operation will be complete and production will begin. While the Stage 1 operation is ramping production in 2021, Talga will begin constructing their Stage 2 facilities. The Stage 2 operation will be capable of 19,000 tons of anode per year and will be a fully vertically integrated process in northern Sweden. Stage 2 will be complete and operational in 2023. This image should help summarize how all these pieces fit together. The stage development process will allow Talga to become a fully vertically integrated graphite anode company. How does this compare to the rest of the natural anode industry? This image shows a typical material supply chain for natural anode. The material is mined and then bounces between different countries and companies to be processed. Each time the material is moved, it costs money, and each middleman takes their cut. I've outlined in red everything that will be done in-house at Talga when they've finished their Stage 2 operation. We'll walk through this entire process in a moment when we look at Talga's mining operation. Earlier, I advised that Talga unveiled their anode material in May of 2018, and I also advised that it takes 18 months for customers to qualify anode material. This means roughly 6 months ago, Talga would have begun negotiations with the first customers who were interested in Talga's product. On the 20th of March this year, Talga signed a memorandum of understanding with a company called Mitsui, which is a giant Japanese-based industrial goods and services conglomerate. The agreement was to evaluate joint development of the operations I laid out above. In other words, Mitsui wants to supply its industrial customers with Talga's anode material, and they want to help finance the construction of Talga's vertically integrated anode project in return for a guaranteed supply. Then, on the 27th of May, Talga signed another agreement for supply with Ferasis. Earlier I spoke about how Talga's customers would want to check the quality and consistency of Talga's product as the company went from pilot scale to 1,000 tons per year or greater. This is exactly what I think the agreement with Ferasis is all about. Ferasis was happy with the qualification testing, and they want their foot in the door for a bigger piece of the pie if Talga can scale and maintain consistency. Ferasis is a second-tier supplier. It's worth noting that the key criteria for this tier list is volume, not quality. In other words, Ferasis could be an up-and-coming, high-quality battery supplier that just hasn't hit scale yet. This looks to be the case because Mercedes-Benz has just announced an equity stake and strategic partnership with Ferasis. Ferasis has plans for a 16 gigawatt-hour factory in Germany to be completed in 2022. The interest in Talga's anode material isn't limited to Mitsui and Ferasis. Beyond the agreements, Talga's been receiving expressions of interest. The total demand in these expressions of interest exceed 300% of the planned annual capacity of the Stage 2 operation at Talga's Vittangi mining project. We'll cover the Vittangi mining project in a moment. Above, I said the Stage 2 operation could produce 19,000 tons of anode per year. If demand exceeds that by 300%, then Talga is looking at around 60,000 tons per year of potential demand. For reference, 60,000 tons per year is enough for 60 gigawatt hours of production, or 2 of Tesla's Nevada Gigafactory. In light of this demand, Talga is accelerating the development of other deposits that it owns at the Vittangi mining project. Let's take a look at Talga's mining operations. Talga owns 100% rights to 3 mining projects in northern Sweden. I was surprised to learn that the Swedes are some of the best miners in the world. There are several mines in the country that simply wouldn't be profitable in other countries at the ore grades and depths that the Swedish mines operate at. This is despite the high cost of labor in Sweden and is largely due to the very low-cost power supplies and high workplace productivity. The first of Talga's 3 mining projects to be developed is the Vittangi project. This is an electromagnetic image of the Vittangi project. The project contains 16.9 megatons of graphite ore, which in turn contains an average of 25.6% graphite by weight. This leaves 4.3 megatons of actual graphite. To put 4.3 megatons of anode material in perspective, the Hoover Dam is 6.6 megatons. This image shows the 4 deposits within the Vittangi project. Of these 4 deposits, the Nunasavara South deposit will be developed first. The Stage 1 and Stage 2 operations I described above will be at Nunasavara South. Nunasavara South contains a graphite ore reserve of 1.9 megatons, which is enough to supply 19,000 tons of finished anode product each year for 22 years. It's worth noting that this supply is from about only 10% of the total graphite ore resources drilled so far. I said in the last video that Tesla requires ridiculous amounts of material for their gigafactories. This is a good time to pause for perspective. If Tesla grows at 50% a year for the next 10 years, in 2030 they'll need 2 million tons of anode per year. In other words, 100 mines like Nunasavara South producing 19,000 tons of anode per year. According to Talga, the 25.6% average graphite content of their Vittangi project is the highest grade graphite ore resource in the world. This makes processing the ore much cheaper. For example, Chinese graphite ore is only 4% graphite. In other words, Talga only needs to fill and move 1 truckload of material for every 6 truckloads of material in China. That's a significant savings in cost and time. The ore is sitting just below the surface of the soil or at the surface. In order to produce 19,000 tons of finished anode per year, Talga needs 100,000 tons of graphite ore to be mined and sent for concentration. Concentration is exactly what it sounds like. The graphite is liberated from the ore and it's concentrated to 95% pure graphite prior to further purification. The first step at the concentrator is milling the graphite ore. Milling means tumbling the graphite in a large drum, which causes the ore to rub against itself and break down into a powder. After milling, the ore powder goes into flotation tanks. The graphite powder is agitated and aerated, causing the graphite to float to the surface. The floated graphite is skimmed away. The skimmed graphite is a thick liquid slurry called graphite concentrate. Overall, Talga's process is relatively environmentally friendly. The typical process for liberating the graphite from the ore and turning it into concentrate involves heat or acid, which respectively are toxic and energy intensive. This is the process that's used in China, where nearly all graphite concentrate is being produced and powered by 65% coal-fired electricity. Above, I mentioned that the ore is 25% graphite. After that 100,000 tons is processed, the result will be 22,000 tons of graphite concentrate. Graphite concentrate is the first step of the anode production process. Let's return to the image of the graphite supply chain. At this point, the concentrate would usually be sent to another manufacturer to be refined. However, Talga will be doing their own refining in-house. In order to understand what happens during the refining process, we have to put the concentrate under a microscope to see what it looks like. Here's an image of a normal graphite flake. This isn't the right shape or size for batteries. Batteries need anode material that's a lot smaller, more rounded, and a more uniform size. The process of making graphite flake more rounded is called spheroidization. This is where Talga's graphite has another benefit. It was formed from the remains of bacteria from around 2 billion years ago. Those bacteria happen to be just about the same size as the ideal particle size for anode material. Graphite commonly starts at around 100 to 150 microns, and then, as part of the spheronization process, it's milled down to an average size of around 10 microns. In the milling process, 50% of the graphite is lost as waste. With Talga's graphite, they only lose about 12% as waste because their graphite flakes are already anode-sized naturally. The 22,000 tons of concentrate become 19,000 tons of refined graphite material after that 12% loss. Returning to the supply chain image, we can see that this refined graphite would then require intense purification processes to raise the graphitic carbon content to over 99.9% before being sent to an anode producer. Again, Talga will be turning this refined graphite into anode in-house. This involves coating the refined graphite with special carbon powders, purifying, and drying. The carbon powder forms a shell around the graphite particles to improve cycle life. Purifying is done by heat to remove impurities, and drying is done to create a final active anode powder. The process is now finished, and the anode powder can be sold directly to a lithium-ion battery producer. Let's take a look at some maps. This is a bird's-eye view of Talga's operations when Stage 2 is complete. This isn't to scale. The purpose is to show the key parts of the operation. The mine and concentrator are in Vittangi, and the anode refinery is in a town called Luleå. The distance between these two sites is 287 kilometers, or 178 miles. However, the area has plenty of road, rail, and shipping that are already in place to serve the other mines in the area. Note the hydroelectric dam and windmills. The entire area is supplied with the cheapest and most environmentally friendly power in Europe. This image shows the electricity cost and CO2 relative to other countries in Europe. The difference in CO2 emissions becomes even more stark when compared to the US and Asia. On average, the CO2 emissions from electricity in Asia are 900 times greater than northern Sweden. It isn't just Talga who's taking advantage of this. Companies like Microsoft, Facebook, and Google have built their data centers in northern Sweden. Zooming out a bit more, we can also see the Northvolt plant is right next door to Talga's Luleå anode plant. If you aren't aware of Northvolt, it's worth looking into. Northvolt was started by two former Tesla executives. It's scheduled to begin production in 2021, will ramp to 40 gigawatt hours per year, and it's now funded by VW and BMW. This map shows Talga's entire European footprint. The rail we saw in the first map carries all the way down to the heart of Europe. Many people outside of Europe don't realize that there's a rail connection from Sweden through Denmark and directly into Germany. Germany is where Talga is running its process R&D and processing graphite ore for sample supplies. Also on the map is Cambridge, UK, where Talga has a product development lab in partnership with Cambridge University and a host of UK customers such as Bentley to develop anode and graphene products. Overall, Talga's in-house anode development team comprises 20 PhDs and engineers spread between their European operation sites. This team has developed several products which include the anode product discussed above, silicon-doped anodes, graphene-doped anodes and cathodes, and anodes for solid-state batteries. I asked Mark Thompson, the CEO of Talga, about these products because it seems like it'll be some time before the battery industry jumps in on these technologies with both feet. Mark's response was pragmatic. He advised that the company needs to stay ahead of where the market is headed and make sure they have products available as new technologies become commercial over time. The first of these products that will likely make its way into the market is Talga's silicon anode product, Talnode-C. Talnode-C is progressing through the qualification process with some manufacturers. Let's move on to profitability. Talga released a project feasibility study in May of 2019 for the Stage 1 and Stage 2 operations. The key points are shown here. The stock bugs out there can crunch the numbers on this and determine the value of the company for themselves. I'm not a financial analyst. This is just information to get you started if you'd like to do some analysis. Please do your own due diligence before investing in any company. At a more granular level, how much will this product cost versus others on the market? This slide shows Talga's production cost for anode at $2,000 per ton. The market price for finished anode material can be anywhere from $6,000 to $20,000 per ton. Talga will be selling their anode for about $11,000 per ton. $11,000 per ton market price minus $2,000 per ton production cost is $9,000 per ton after production cost. As above, Talga has a capacity of 19,000 tons per year run rate coming online in 2021. This comes to $171 million a year for a company currently worth about $90 million US. Although we covered demand for Talga's anode product earlier in the video, it's worth calling out one of the main reasons why that demand is so high. Europe only has a few small gigafactories, and eventually it will need more gigafactories than the United States. This means that Europe will have the highest growth rate of any market, which is illustrated here. If you'd like to know which companies are building in Europe and when, this image is a great summary. In the next few years, there will be an explosion of gigafactories across Europe. At the beginning of the video, I suggested that we need to cover 3 questions about Talga. 1. Do they have a viable product? The market certainly thinks so, and the demand is high enough that Talga is accelerating the development of their other graphite deposits. 2. Can they scale? With the Mitsui development agreement, it looks like financing is a matter of course. In terms of actual delivery, it's looking good so far. Talga is hitting the targets provided in their timelines. 3. Can they turn a profit? It looks promising based on Talga's feasibility studies, the cheap power, the high ore grade, access to infrastructure, Swedish mining, and vertical integration. That's my view, but it's up to you to decide for yourself. The next question you're probably wondering is whether I personally would put money into Talga or Novonix, and which one is going to, quote, unquote, win. The answer to the first question is that I invested in both in the past, and I plan on investing in both again in the future, which should automatically answer the second question for you. I think there's a market for both products, and the market will be ridiculously large for any manufacturer in the space that can provide quality battery materials at a decent price. Both companies are signing agreements and have engaged and knowledgeable leadership. My only reason for selling stock in either company recently was to eliminate any conflicts of interest in making these videos. Talga and Novonix appear to be the only anode manufacturers outside of Asia that are viable. This is important for two reasons. 1. We're in a post-COVID world where all countries are trying to secure local supply chains. In fact, Talga's mine has now been designated a strategic natural resource in Sweden because it's the largest graphite mine in Europe. This means Talga's mine is a national priority for Sweden to support development. 2. Most graphite comes from China, and that graphite is extremely dirty. In other words, it's not good for the environment. Both Novonix and Talga offer greener alternatives. Both companies look set for parabolic growth if they can execute in the next 2 years. Novonix is well positioned to tackle the synthetic graphite market, and Talga is well positioned for natural graphite. The question is, what are the positives and negatives of synthetic and natural graphite? In the next and final video of the Anode series, this is exactly what we'll be covering. If you enjoyed this video, please consider supporting me on Patreon with the link at the end of the video, or snag something off the merch shelf below. I'm also active on Twitter and Reddit. You can find the details of those in the description, and I look forward to hearing from you. A special thanks to Bernard Berry, Stuart Steele, Terry Shimmick, Brandon Kruger, and Chris Hopkins for your generous support of the channel, and all the other patrons listed in the credits. I appreciate all of your support, and thanks for tuning in.